All right, good morning, everyone. We're doing great. So, welcome to the fifth edition of our Cairo Bootcamp, and it's an opportunity for us again to onboard developers into the Starknet ecosystem. So, we're going to be unraveling all what Starknet is all about, what Cairo is as a programmable language on Starknet. So, if you want to build any scalable application, just the way we started our journey into smart contract development using Solidity on Ethereum, we have a language called Cairo, which is what you're going to be using to build applications on Starknet. So that is what we're going to be exploring in the course of this fifth edition of our Cairo Bootcamp. So so you're welcome once again, and I'm Dave, and I'm here to take this fundamental session. I'm going to explore all of what Cairo has to offer us as developers. So, why are we here? So we're here because Cairo Bootcamp is a very strong pipeline for us to onboard developers into the Starknet ecosystem. And it's a Starknet Foundation initiative. So we're going to be having classes 3 times a week. In this order, we're going to be having sessions on Monday, Wednesdays, and I think, I'm sorry, this is supposed to be Friday. This is Friday, actually, so don't mind that. I think I will do that right away. So this is supposed to be Friday. Yeah, so it's supposed to be Friday. So Monday, Wednesdays, and Fridays, same time, 11 a.m. West African time. So what are our expectations, right? So we're going to be having Q&A sessions, we're going to be having quiz and homework, and we will expect everybody in this Cairo Bootcamp to be part of the Discord channel. So we have a dedicated Discord channel on our server. So we're going to share this. I think have access to it. So you can actually be part of all the resources that will be shared. And again, all of our teachings will be recorded, and anybody that wants to look at these videos after this class can actually visit all of our video resources that will have a dedicated playlist on YouTube. So so subscribe to our channel for that. So we're going to be covering quite a number of things, and one of those is this morning we're going to be covering the fundamentals to what Cairo is, what Starknet is, so all of those things in this particular segment. I'm just going to give you an overview of what we're going to expect. So we're going to explore the fundamentals, introduction to Starknet and Cairo. Then we're going to eventually dive into Cairo. Then afterwards, we're going to cover Starknet contracts. Then afterwards, we're going to be covering testing using SM Foundry. Then we're going to be covering Starknet components, and front-end integration, how you can actually integrate the front-end to your smart contract that you've built in a couple of sessions coming afterwards. So we're going to be having gaming, so fully on-chain games, FOCG with Dojo. And then afterwards, we're going to be exploring Starknet nodes, what it takes for you to run a node on Starknet. So we will have amazing teachers that are going to cover each of these sessions. And I'm very, very happy and excited to say this, that all of the persons that are teachers and mentors covering each of these topics have proved their methods in the past. And that is why we're confident that the outcome of this Cairo Bootcamp is going to result into solid developers who really understand the fundamentals with good understanding on how to deploy application on Starknet. So what are the condition requirements? So we're looking at attendance, and so there are different categories. So we expect that everybody that is going to participate in this class should take all of our attendance very seriously, the classwork, and at the end of the day, we're going to have a capstone project. So this really qualifies you for graduation. And then you're going to receive a SPOC. So it's kind of like an on-chain badge that guarantees that acknowledges your participation in this bootcamp. So yeah, so thank you. We will discovery system. We have quizzes, we have assignments, we have completed Starknet's challenge. So Starknet is a gamified approach to learn Cairo and Starknet contracts. We're going to learn all of this. So you're going to go to the ranks, make sure you've completed Starknet. It's very important. That is the most important guarantee that you completed this bootcamp. Then also, as a bonus, you can actually proceed to Node Guardians. So Node Guardians, for those of us interested in security, you want to explore security with Node Guardians. So yeah, so thank you. I think that's that. So we're going to be exploring the fundamentals today. So the fundamentals, we'll be covering what Starknet is all about, right? Why Starknet, why Cairo, Bitcoin integration. Yeah, so we're going to be doing all of that, and we're going to have test questions because of this session this morning. So yeah. So before we start, we're going to be exploring some of the core fundamentals. So you'll be seeing some of these terminologies from time to time, but it is my duty this morning to explain all of them, what they mean, how you can actually approach them and know what they mean whenever you meet them in the course of your journey, all right, in this ecosystem. So we have Starkware, we have StarkX, we have Starknet, we have Starknet Foundation. So what do these all really mean? So yeah, Starkware is the company that created this whole concept called collective roll-up. And that's what we're here to celebrate. Yeah, because it is on the basis of their research that we have StarkX and Starknet. So what is so at the back of your mind, anytime you see Starkware, know that it is a company, right? It's a research and development company that came up with this scalable roll-up solution called Starknet. But their first approach to scaling was StarkX, right? So kind of like a permissioned approach to scaling Ethereum. Or what that means is if you want to kind of like deploy any application on StackX, which is a layer 2 scaling solution, what that means is you write your contract and they'll give you an API key for you to deploy your solution on Starknet. So yeah, so that was the earlier version of the approach to scaling Ethereum. Then eventually that could not scale because for you to write any application, you must reach out to the team, they'll give you an API key, then you deploy. It's not really scalable. The concept of decentralization is not fulfilled with packets. Hence, the modified approach to create a permissionless layer 2 solution that's going to leverage ZK technology. We're going to talk about that. Yeah, that is Starknet. So yeah, Starknet is a permissionless L2 solution, right? We're going to learn about all of what Starknet is all about. That is the whole essence of this bootcamp. So if you write your Starknet, if you write your Cairo Starknet contract using Cairo, you don't need permission of the Starkware team for you to deploy it successfully as a product on the network. So it's just permissionless, just the way you have your Solidity. You don't need anybody from the Starknet, anybody from Ethereum Foundation to deploy your Solidity-based application. Do you? You don't. You just write it, just simple script, whether hard hat or Starknet Foundry or Foundry, right? Just from your command line, you deploy and it's live on the network. In the same way, that is what happens when you build any application using Cairo. You want to deploy it on Starknet, which is a permissionless network. Yeah, so Starknet Foundation is it's a non-profit organization that enables research, that promotes applications to be deployed on the network. So if you have any research idea, you may give grants and then enable developers to thrive in the ecosystem. So yeah, so that is the different concepts so that we don't mix them up in the course of learning. So yeah, I hope this is clear. Yeah, so if you have questions, please feel free to draw my attention to your questions. You have a question? Any question? No problem, thank you. So what? StarkX, yeah. So StarkX, like I said, is the first approach to scaling. It's kind of like a permissioned environment, right? So if you want to write any Cairo-based application for you to deploy on the network, you need you need to start a team for them to access to deploy on the network, right? So that's the first approach. But right now, I think applications that and BYDS, we have so rare, quite a number of them, they leveraged Starknet. Yeah, so but right now, the core focus for developers in this current dispensation is Starknet. So because it's permissionless, you don't need access to any Starkware team to deploy your Cairo-based application. Yeah, I think that is clear. So yeah.
Is Starknet is it an optimistic protocol?
No, we're going to talk about that. It's a ZK, zero knowledge. So ZK, so we're going to learn about that in the course of this class. So yeah, any other question? Starknet, for purpose of clarity, is a ZK stroke validity rule of solution. We're going to learn about that. So why Starknet? So there's a problem with scaling on Ethereum, right? There's a problem. How many of us have used L1 Ethereum? If you have, you will know what I'm saying. So there's a problem of costs. That's cost. So you want to transfer probably your tokens. Sometimes it's very high, like the cost of transferring that asset from party A to party B. This is a problem because, especially here in this part of the world, nobody will pay that huge amount to transfer value, right? So let's say you want to transfer 5 USDT, and you need to pay $3.5 or $4 as transaction fee, right, on L1 because of the congested nature of the network. So this kind of like affects the opportunities for people to use Ethereum, right? So that was why a lot of approaches came up to scale Ethereum so that transaction fees will be cheap because that is the basis of scaling. Yeah. So we have, like we mentioned earlier when we talked about introduction to our first phase of learning, right? We talked about the blockchain trilemma, right? And we talked about decentralization, security, and scalability. So yeah, what is decentralization? The degree to which a chain operates without reliance on central entity. So that means that you don't really rely on any trusted setup, right? So everybody in the network is operating independently. There's a core logic that ensures consensus. Once consensus is reached, every party operates as normal. So basically, that is the basis for Ethereum to thrive. That is why Ethereum have thrived so far. So yeah, also security. Ethereum is a very solid network that guarantees security. So the capacity of a network to guard against attacks, right, like double spending and malicious activities, ensuring data integrity. So all of these things are solid on Ethereum. So you can guarantee that Ethereum has decentralization, is secure. However, the third component of the blockchain trilemma is scalability, right? So the ability to handle increased transactions without compromising performance and cost, right? So what is the cost of executing transaction on a network such as Ethereum? So it is dependent on the state of the network. So transactions in network is dependent on how congested the network is. When transaction is said to be low, when the network is less congested. Transaction is high when the network is congested, right? So low fees equals to what? It's a pointer toward less congestion, less activities on the network. So when we have multiple activities on the network, like when we have price actions, right? So probably there's a spike in what's it called in the price of heat, right? So everybody wants to kind of like perform one or two activities on the network, or probably when there's kind of like a forceful decline of the price of assets on the market. So people want to kind of like supply more collateral on DeFi protocols, that these activities kind of like increase the traction on the network, and that results to a clogged network. So if you want to use the network, you must pay high gas fees. So it's kind of like affects the cost of using Ethereum. So this is a problem. So on the basis of this problem, a lot of solutions came up to address this problem so that people will have to pay very little fees and enjoy speed, right? So yes, that is what led to a lot of our research approaches. We're going to learn about all those research approaches, right, in the next slide. So yeah, so basically blockchains must balance decentralization, security, and scalability. So for Ethereum, we've noticed a trade-off, right? Where it has security, it has decentralization, it's kind of like falls short in the expectation for scalability. So that is the problem. That is why we have L2s. So think of it like this. We have L1 and L2. So yeah, so basically transactions on Ethereum is kind of like dependent on activities. Yeah, the transaction cost is dependent on activities. So when there are less activities, you pay low fees. When there's high activities, right, you pay high gas fees. Yeah, so this has resulted to the inefficiency of using Ethereum. It was on this note that a lot of research approaches came up, right? We're going to talk about them. We have the ZK approach, we have the optimistic approach, scaling Ethereum. So this is all about blockchain trilemma. So yeah, so when a new state is proposed by a block proposer, validators execute all transactions within the block till they validate and attest the new state, right? We talked about this when we exposed everyone here to Ethereum when we started this cohort. Remember, right? So yeah, so once a block proposer proposes a new block, validators within the network will have to execute they perform attestations to make sure that that new state is valid, right? So this results in slow transaction throughput and high gas costs. So yeah, so it's kind of like a proposer within a validator set proposes a new state. All the validators that form a committee will have to attest that this new state is valid, right? That attestation is work on its own, right? So that's kind of like not really an efficient approach to scaling. And that is why we have slow transaction throughput and high gas costs, right? So whereas transactions in the mempool are left unattended to because of this process. Yeah, the block proposer by design, right? On Ethereum, there's what called a slot. That's every 12 seconds, a new block is proposed. That's a new state. When you hear new block, new state, new block, new state. So basically that. So every time a new block is proposed, validators within a given set, like yeah, that forms a committee, will have to attest that this state is valid. So that is kind of like a problem, resulting in all of the challenges we face in scalability for Ethereum. So yeah, slow transaction throughput and high gas cost. So yeah, why scaling? High gas fees, which is a problem, transactions becomes expensive during network congestion. Like I said earlier, slow transaction throughput, the speed of handling transactions. So Ethereum by design cannot only handle 15 transactions per second. So, and as more users and dApps need faster and cheaper transactions, the network costs for executing a given transaction grows. And that is the reason for scaling. Is this clear?
Yes. So,
Yes, your question, please.
okay, that's if someone and does the question, right? Because of the network, because it's going to be slow. It's not going to still know why is it because of that network it's making the transactions? So is that
I don't get you coming in.
and you said now like that when you do the transaction because of the network, the gas fee will be high. So it depends on the network gas fee because
So if you follow those, and I know I don't know whether you were there when we started. We said something, right? There's a protocol logic on the core of Ethereum, blocks are created every 12 seconds. That's what we call a slot. Every 12 seconds, as designed, a new block, a new state is created. So what happens? You cannot go against this core standard. So whether you're doing 1 billion transactions that have been executed all across the globe, the network can only create a new state every 12 seconds. So that's the problem. So what happens if we have hundreds to thousands of transactions that are pending? Those transactions will not be added to a new block. Like there's no way to break that 12 seconds rule. So yeah, so that becomes a problem. That means for you to have your transactions added to a given block, you must pay high gas fees. If you don't pay high gas fees, your transaction will be pending. It will never be aggregated to be part of a block. So that's a problem. So what regulators will do, they will look at what transactions have economic benefit for them. Who paid higher gas? So if you pay higher gas, they keep the transactions in the block. That's the problem. That's the result of the whole thing. Yeah, so I hope this is clear. Yeah. So, like I said earlier, we have different scaling approaches, and that addresses your question, Usman. You asked the question, is Starknet an optimistic roll-up? I said no, it is a ZK roll-up. It's a zero knowledge roll-up. So yeah, we'll talk about scaling Ethereum. So just the way we have cars, right? We have front wheel drive cars and we have back wheel drive cars, right? We agree, Japanese cars are what? Front wheel, German back wheel. Like, yeah, so most of the times have Mercedes, Audi, Volkswagen, they're all back wheel drive cars. And then Japanese cars, Honda, Toyota, yeah, and the rest of them. They are different engine designs. At the end of the day, what is the goal? To move.
That's true. Yeah.
True or false? To move from point A to point one, B. How they achieve their engine design to propel that particular car forward differs. Does that make sense? So in the same vein, how roll-ups, how different teams achieve scalability differs. So yeah, so how some teams, they came up with an optimistic roll-up approach, right? So what does that mean? They leverage the optimistic stack, OP, the scaling solution, which assumes that every transaction included in rollup are valid by default. So they are saying, okay, we can have hundreds to thousands of transactions, and until somebody disputes the validity of all these transactions are assumed to be valid. So yeah, validators on the OP net using the OP rollup approach submit batches of transactions whose validity can be challenged by anyone who submit a fraud proof within a 7 to 8 day waiting period. That's like 1 week. So if you want to kind of like, if you execute a transaction that involves withdrawal of your assets from an OP stack to Ethereum, it takes 7 to 8 days for you to have an eventual success. That is, the success is determined by one thing. If nobody raises a fraud proof, right, within this 7 to 8 waiting window, right, that transaction of withdrawal is assumed to be successful. So we have a lot of ecosystems leveraging the OP stack. Like, I'm going to talk about them. So yeah, before we dive into zero knowledge eventually. So we have OP, let's go this way. So we have scaling. So on one hand, we have something, we're going to come back to this. So on one hand, we have OP, optimism. On one hand, we have what ZK. So optimism for short, OP for short for OP, for optimism. Then ZK for short for what? Zero knowledge. Now, we have a lot of ecosystem leveraging the OP stack. We have Arbitrum, optimism itself, actually, yeah. Then we have, I think, Lisk. Then we have Base. All of these L2s are leveraging the OP stack. Then on this hand, we have ZK Sync. ZK Sync. we have Scroll, we have Starknet. So basically, we're going to, the core focus of this introductory phase is to talk about Starknet. Right? But we're going to learn about a little bit about the different approaches and how they scale and why Starknet has proved its method as an efficient and better solution for scaling. So yeah, so on the other hand, we're looking at the zero knowledge or validity roll-up, right? So what is zero knowledge? How do I prove that one that without revealing details of the outcome, right? I know kind of like a mathematical way to prove, right? You prove that you know something without revealing details of what you know. Does that not sound confusing?
Yeah.
So I know that you have $50 without revealing details of how I know that you have $50. That is what zero knowledge is all about. So they're using a mathematical approach to derive the outcome of computation. So we're going to give a periphery of how it works, right? Not really diving into ZK because ZK is purely mathematics, right? But Starknet on its own is abstracting all of that away, leveraging this solution to achieve scale for Ethereum. So yeah, using zero knowledge proofs, a cryptographic technology allows an entity to prove they know or have done something without revealing details of the underlying data, right? So ZK rollup is divided into two. We have ZK snacks, as used by ZK Sync, and then the stack, which is an approach used by Starknet. We're going to learn about the differences between snack and stack. Yeah. So yeah, in all of this, all the laying, there are two solutions. There is something in common. They have something we call what? A sequencer. So like I said earlier, we have optimistic and zero knowledge based rollups, right? This is kind of like an overview of how it works. So you see something that on everybody settling on Ethereum, this is kind of like the node network on Ethereum. So at the end of the day, all the node operators, if you have text2 ETH, you become a validator. So you're helping to secure and maintain the security of Ethereum, right? What happens is Ethereum becomes what? A settlement layer where all of the data that probably anything you do off-chain, like whether using an optimistic rollup or ZK rollup, you still send all of your data to Ethereum. So yeah, so that is what all of these, there are two scaling solutions have in common, right? They have Ethereum as a data layer. So basically, the approach for sequencers right now is centralized because at the end of the day, most of these protocols, like yeah, all of these layer 2 protocols, they have a centralized sequencer. So these sequencers receives all their transactions in the network. So it bundles them to form blocks, and then at the end of the day, a proof is created, and that proof is sent to Ethereum. Does that make sense? We're going to learn how that works eventually. We're going to talk about the transaction life cycle. Does that make sense? Hello, guys.
Sequence are just a computer like a node.
So yeah, so just in your head, know that we have what? L2, and we have what? L1. So anytime you mention L2, it can be either of these. It can be what? OP or what? ZK. Whatever you're doing, right? However you're doing it, right? When you talk about OP, this is the OP-based protocols, right? And for ZK, you have this, and they're all layer 2s, right? At the end of the day, they have something in common. When you're, just think of it like a story building. The ground floor is Ethereum, then the floor above it is what? Is the L2. However they are using it, whether it's an OP stack, whether it's a ZK stack, one thing is common, that they bundle, aggregate hundreds, thousands of transactions, then send one proof. That proof will verify as a valid if that could be verified on Ethereum, then that means that all of the transactions executed off chain, like off Ethereum, is valid. Does that make sense?
Okay.
So it's just like somebody's so let me give you an analogy. If I'm going to go to the next town, and all of us we have to all of us are going to the next town, we're going to Abuja, right? But what happens? I'm going with my car, you're going with your car, you're going with your car. Is that not expensive? It's not expensive. Somebody's saying, you know what, instead of all of us moving with our different vehicles, so I'm going to bring a bus, everybody enter the bus, we'll go to Abuja. It's not cheaper.
Yeah.
So that is what L2s are. So L2s are like that bus, they aggregate different transactions, then when they get to their destination, they verify that every transaction is what? Valid. That is all.
So the other one is
So Ethereum is the settlement layer that vets all the aggregated transactions that are included in the proof. Does that make sense? So yeah, how they achieve their proving systems is what differs. Just like I gave an analogy earlier of car manufacturers, right? We have front-wheel drive and have backward drive. However, they design their engine. The goal is what? To move from point A to point B. So yeah, in all of these, it has been proven again and again that the ZK scaling approach is more efficient. Yeah, I'm going to explore that. I don't know if we have any other question. So yeah, so right now, as much as sequencing on L2s is centralized, Starknet is showing strong effort to decentralize its sequencer so that people running validator nodes will eventually become sequencers in the future. So yeah, I think so far so good. I think they have kind of like opened it up. They don't have a single sequencer. They're the first L2 solution that created a multi-sequencer approach. Yeah, and in the future they have plans to further decentralize it. So far so good.
Okay.
Remember, the idea is to make sure that we remove single points of failure so that nobody wholeheartedly relies on a single entity, so that there are no single points of failure. So if this entity goes down, what happens if the sequencer goes down? That means no transaction can be executed in the network. Or if you have multiple sequencers that are decentralized, that means if one goes down, other sequencers will be incentivized to aggregate transactions to form blocks, and that kind of like removes the challenges of a single sequencer. I don't know if that makes sense. A single point of failure is always a problem. If a sequencer is targeted and is down, that means nothing can happen on that network. So if you have multiple sequencers that are decentralized, performing independently, however the case is, there's always an entity, a component that is going to aggregate transactions to form blocks. So that kind of like maintains the health and the security of the network. So yeah, so basically that. So yeah, what is the pros of this approach, right? To have high performance, Ethereum security is guaranteed, but the cost, the cons is that it is kind of like a centralized approach, and we have fragmentation. That means activities performed on a given chain is isolated from the other chain on the L2 network. I don't know if that makes sense. So activities that probably you're performing the transaction or kind of like a different operation on a given network, it's kind of like completely isolated from the other network. So there's no a synchronization amongst all of these separate scaling networks. So yes, that's the only disadvantage. But it is fast, and it kind of like has been proven to guarantee Ethereum's security at the end of the day, because everybody's leveraging Ethereum as a data settlement layer.
So question.
No question, yeah.
So you just said that there's fragmentation, there's no like interconnectivity between connection on the multiple chains. Why is that necessary? Because for example, I heard that optimism that building something called a super chain, so that all chains on the OP network can
Whether OP network or not, liquidity on the OP stack is isolated from Starknet. We have multiple scaling approaches, all of them with their own fragment. Like everybody's siloed.
Question is why would they being able to interact be
It's a problem by design because that is what a lot of people are building. They're searching on how to kind of like reconnect all of these isolated networks as L2s. So there's a platform called Preconfs. I think some guys when I was in I attended a couple of talks. So the idea is to kind of like it's called base OP. So they're looking at a concept called pre-confirmation, right? Both on L1 pre-confirmation and L2 pre-confirmation to solve liquidity fragmentation issues across all of these isolated networks. Yeah. So why what you're saying works for the OP stack? So all these networks, they have liquidity, yeah, because they're leveraging the OP stack. Liquidity on one of either Arbitrum is available on disk and base. It's kind of like still fragmented because it is not accessible to to ZK, Starknet, and Scroll. So whatever you're doing here is kind of like in isolation. So yeah, so there fragmentation should work regardless of whether it's OP or ZK. So that is the problem. I don't know if that answers your question.
not exactly, but yeah, it clarifies things.
Please, I want you to clarify anything you want. That's the essence of this question.
What I'm trying to understand is it because all their tools on Ethereum, that is why there's will I say a need for them to be able to communicate?
No, it's because of the stack called OP stack. It creates an avenue for everybody to interact.
All right.
If you build any L2 leveraging the OP stack, liquidity on your network is available to other OP based L2 solutions. So yeah. So
Why is that necessary?
It's because
Why is it a good idea?
it's not really. It's a good idea because it solves inter network liquidity problems, right? But then overall, outside of the OP stack, we have the ZK stack. What is liquidity available here? No, it's not. So it's still the problem.
Why is that? Why is having liquidity on OP available on ZK?
Because why is having liquidity
like available on OP?
Mm-hmm.
Why is having liquidity on OP available on ZK something that you should be considering?
It's a solution because none of these networks should work in isolation, right? So if I have liquidity, I mean, if I have a pool of a DeFi, let's say you built one staking protocol, information about that staking protocol should be available to other networks outside of that your stack, in this case ZK. So if you deploy something as a DeFi solution on Starknet, it should be available to this base. That's the problem. So you can actually solve that problem with your knowledge of this class. So cross-chain messaging, right, is very important. So you want to go deep, low level to understand how, because it's messaging, right? If I think there's a network. So if there's kind of like if it's negative use if you're connected. So basically, if we have a solution where you can implement cross-chain messaging, right, between OP and ZK, what you're saying works, right? So automatically, if message can be sent, that means value can be sent too. Yeah, so you can actually read and write, and basically that solves the problem of liquidity fragmentation. Any other question? That could be something you want to work on. I'll be happy to help you as much as I can. Yeah, so what's the difference between the optimistic roll-up and the ZK-based roll-up? So yeah, we have, like I said, in the optimistic approach for scaling, everything is assumed to be true until a fraud proof is what? Yeah, until
is created.
Yeah, so if something creates a fraud proof, that means something, you have to get full access to this slide after this class. So yeah, yeah. So basically what that means is the sequencer for is assumed to be honest. That means everything that has been aggregated as transaction, right, is assumed to be valid within 7 to 8 days. right? Afterwards, what happens? If no fault will be generated to dispute the validity of all of these transactions created within this challenge window, it's called a challenge window, right? 7 to 8 days, otherwise known as challenge window. If nothing happens, what happened? What does it mean? It means that all of those things that has happened on the network is assumed to be valid, which is kind of like a bit risky because it has its challenges, right? So yeah, because you can kind of like if there's invalid transaction and nobody challenges that invalid transaction within that challenge period, right? What that means is you have added an invalid transaction to the states of the network, and it will always be referenced. So yeah, so it kind of like leaves room for for kind of like errors and all of that. But in the case of the zk rollup approach, right, there is always a proof and there's always what a verification, and this happens within, like we talk about the time, like we talk about the timing, right? So basically that, so there's a prover for the zk rollup architecture, and there's a verifier. So for everything that is proved, that for which a proof was generated, there will be a verification of that proof. That means there is no room for anything that does not belong to be verified. If it's not valid, it is eventually dropped during the verification process. So yeah, so the security, so proofs kind of like very complex, and then validity proofs simpler to implement. So we have L1 finality. Like I said, it takes 7 to 8 days for settlement between L1 based OP rollup and Ethereum. However, on Starknet, it takes so the time it takes for all of the transactions and states that have been created on L2 to be verified on L1, right? So for this, it takes 7 to 8 days, right? So that means if you want to withdraw your asset from OP to Ethereum, so it takes this number of days. I think this is clear this way. Let's say 7 to 8 days. Whereas for this, it takes some hours. They say 6 to 8 hours, dependent on the fit of the network sometimes. Yeah, so basically that. So we have L2 finality and L1 finality. We're going to learn about that eventually. So block space, state root. So block space, we're going to talk about this when we talk about architecture so that it makes a bit more sense, right? So we have block space. I think both of them will expound them during the transaction life cycle session. But note this is very important. I don't know if there's questions. There are questions. In all of this, why are we very bullish about Starknet, right? The Starknet is a permissionless layer 2 net solution for not only Ethereum, but for Bitcoin. So the approaches and research and development that's currently ongoing on how to further extend scaling to not just Ethereum, but for Starknet, for Bitcoin, right? So yeah, multiple transactions are bundled off-chain. All of these transactions bundled off-chain, and then a single compressed proof is sent to Ethereum mainnet, reducing gas costs and improving transaction speed, right? So that is one of the benefits, and it leverages zero knowledge. Zero knowledge in this case, not for privacy, because everything you do on Starknet, that does not mean that it is kind of like private. Everything you do on Starknet is public. I don't know if I'm making sense, because during the core process of introducing ZK, I said that you can note, you can tell that something is A or B without revealing the details, right? So that you don't think, oh, it is on the basis of privacy. For Starknet, ZK, leveraging ZK is for scalability, right? We're going to talk about that. Please, are there questions? So I don't know if there are questions from the audience, please let me know. So Starknet increases transaction throughput and decreases transaction costs. So on one hand, transactions are faster, while on the same vein, transaction cost is practically reduced. And it leverages a future-proof scaling approach referred to as what? Stack. So Stack, what is Stack? Some of us were wondering what is STARK. It's called Scalable Transparent Argument of Knowledge. So yeah, so this is the problem for Ethereum. What happens on Ethereum, right? So every time a new state is what? Created by a block proposer, every validator within that given set, right, called a committee. So for every new block proposal, there is kind of like an attestation. It's a two-way process. So a block proposer, like we talked about that earlier when we talk about nodes on Ethereum, right? I mentioned this, and this is the inefficiency of Ethereum, right? So for any block proposed, all the validators must perform an attestation to ensure that that state is valid. State is same as blocks. I don't know if I'm making sense. So anytime a new state is created, you can actually interchangeably say that a new block is created. So yeah, so validators use almost the same computation to attest the validity of the new state. So that is why we have multiple validators doing the same thing as the block proposer. Whereas on L2, right? So it's just a fraction of effort used to generate the proof. Like, yeah, so you can see it's not the whole block, it's just a fraction of it. Does that make sense? So yeah, with reducing the effort used to verify that a given state is true. Yeah, also what is validity proof? So interchangeably, you can say ZK or validity proof. Does that make sense? So yeah. So validity proof is a use case for ZK proof. Convincing the verifier on L1 of L2 state without sharing transaction details. So this is the basis for saying that Starknet is what is ZK rollup. So yeah, so you're going to convince. So we're going to learn about the Starknet architecture. So we have so I can clean this, right? So we can say we have the sequencer, the prover. This is on L2, in this case Starknet. Then we have here L1, which is in this case Ethereum. So let's say Ethereum, the star. All of these things, then we have the verifier. So we're going to talk about different components. All of these components, we have the sequencer. The sequencer is the component responsible for accepting transactions. We're going to talk about transaction lifecycle, so we're going to understand better, right? So when you send a transaction, the first point in the whole of this architecture is the what? Is the sequencer, right? The sequencer aggregates all of these transactions, and afterwards, a proof is generated for all of these bundled transactions that form different blocks. So yeah, your transactions are created to form blocks, and multiple blocks, a proof is created from all of those multiple blocks. Then the verifier. The verifier component is a contract on Ethereum, right? So there's a verifier contract that attests to the validity of the proof. So this proof is kind of like a lean version of, if you open this proof, you see all the transactions, right, that were executed. So yeah, so it is on the basis of the fact that when a new state is created, that's when a new, so the basis of ZK is premised on this line here. So yeah, the verified contract on L1 is aware of all of the things that have happened on L2 without revealing the details of that reveal. So this is the basis for calling Starknet a ZK rollup. Yeah. So like I said earlier, this does not make Starknet private. That means every transaction on Starknet is accessible. You can actually visualize them on Starscan, which is the way we have what Etherscan is to Ethereum is what Starscan and Voyager, the block explorers, are for Starknet. So yeah, so it makes verification very efficient, very proof, very low. So it's based on stacks and not snaps, and then efficient proving and verification. So yeah, so this is an improved way to visualize the effort used by sequencer to execute transactions and for the validator to verify a given transaction. We want to liken the whole process as validity proof and computation. So how many of us have used a zipping application? Zip, you have like 1 terabyte,
Like we have.
yeah, WinRAR, yeah. So you can send 1 terabyte as an email. Can you? You have to zip it. You zip it, compress it, and send that compressed version via email. So yeah, so that's zipping feature. We can actually liken it to what happens in compressing the size of transactions. Yeah. So yeah, so we have a validity proof is generated, so it compresses all of those. So now think of it like a broom. So yeah, so a broom, if you want to kind of like take out each broomstick, yeah, it's kind of like scattered, but kind of like somebody said, you know what, can actually take all of these broomsticks, tie it together, kind of like it's kind of like a big handy and it can be used. So in the same vein, this will not really be the real analogy, but you understand what I'm saying, that you can actually have multiple transactions and a proof is created for all of these transactions and compressed. Yeah, so that's how we want to validity proof is validity proof is Starknet. I think it's click on all of them are CK proving approaches, right? Make one. I don't know. Can somebody? I don't know. Can somebody turn on their stuff? All right. So yeah, people align him. Please, is it clear? If it's unclear, please let me know. Draw my attention so I can actually go by it. So yeah, so we have stack and stack. So remember, both of them are what? ZK-based scaling solutions, right? Whereas on one hand we have stack, which is what? Scalable, transparent argument of what? Knowledge. On the other hand, we have what? Snap. Are we good? Yes. So yeah, so we have the stacks and the snacks, right? So what is stack? Stack is what? Scalable, transparent argument of knowledge. And on the other hand, we have what? Snack, which is what? Succinct, non-interactive argument of what? Knowledge. So it is ZK Sync that uses what? Snack. I think ZK Sync, I think Scroll, I think they use Snack. Then Starknet is the only known scaling approach. I think there are other ones right now. I think Succinct Lab, they're trying to like use Stack.
So it's not use something for
Succinct, succinct, non-interactive argument, both of them argument, AR of knowledge. Whereas on the other hand, we have what? Stack, which is what? Scalable,
Yes.
transparent, argument, which is both of them, of knowledge. So yeah, so that's basically how that works. So yeah, on one hand, we have Snap solutions like zk-sync. On the other hand, we have Starknet leveraging Stack. So what is the difference? What are the differences between these two? So verification on Stack, on Starknet is kind of like dependent on what mathematics students here. So yeah, if it takes S, it takes log raised to power X to verify. So yeah, verification is dependent on what? Dependent on what? So it's dependent on this formula here, log 2n. Whereas on Snap is very constant. Proof size 400 kilobytes, and on Snap it's 228 bytes. Very small. The proof size is small, right? Then proving time 1x, then 10x, then trusted setup no, then yes. What does this mean? It means that you need a trusted entity, a trusted setup to initialize Slack. That's kind of like its advantage. I mean, it brings in what? The trusted entity, which is what blockchain is trying to eliminate, right? Removing and eliminating trusted entities, right? So kind of like a disadvantage for Slack because you need a trusted setup, right? But for Slack, for the official tools, you don't need a trusted setup, right? Then quantum secure, right? Quantum security, we talked about quantum security, right? When we explored our bootcamp earlier. So quantum security, what are the hashing algorithms, right? ECDSA, right? All of those things that guarantees that the cryptographic hashes, right? The hash functions that guarantee the security of that chain, right? If there's quantum compute tomorrow, are those cryptographic guarantees safe? Does that make sense? Hello? So can somebody run multiple, because we know that you cannot derive a private key from what? From a public key, true or false? For quantum security, with quantum computers, you can run multiple compute and there's possibility for you to reverse it, right? If that network is not quantum secure, it's possible that the private key can be retrieved from the one public key. And what does that mean? So every owner of asset on that chain, if I run that quantum compute on that network, I mean, I can derive your private key and I what? I'll look for the guys that have assets and move it. That is kind of like a risk for quantum security. In this case, on one hand, Stack is quantum secure. I mean, even with the introduction of quantum computers in the future, there are no risks. However, for the other hand, for Snacks, it's kind of like not quantum secure. So yeah, quantum security, like I mentioned earlier, leverages the principle of quantum mechanics, such as superposition, entanglement, and quantum interface to process information, right? Instead of using bits, which represent either 1 or 0, quantum computing using qubits, a unit that can exist in multiple states at the same time, such as 1, 0, or anything in between. So yes, no, and maybe, something like that. So kind of like making it great to solve certain puzzles like factoring integers much faster than today's powerful computers. On the note of security, it is Stacks uses a post-quantum cryptographic assumption. All right. So yeah, Stack rely on hash functions for their security rather than on number theoretics such as elliptic curves and discrete logarithms on which snaps rely, right? So that is how quantum computers can actually affect scaling approaches like stacks, and users can actually be affected if that becomes a risk and a reality in the future, right? So Cairo is not solidity. Please note that. Cairo is definitely not what. So there are a lot of differences. Remember, all OP stacks, what you need, what you need is what? The same solidity you wrote for a smart contract to deploy on Ethereum. In just what? Same solidity you deploy it on what? On the OP chains. Does that make sense? You don't need to write any new programming language, but it comes to a problem. Why? Because if you write that language and want to deploy it on Starknet, to no work because it uses a different word, virtual machine. So whereas we have EVM, that's Ethereum virtual machine, on one hand for Ethereum, we have Cairo what? Virtual machine for Starknet. That's why we're using a completely different language that we're not used to, right? We've been learning Solidity for the past couple of months. Now we're going to a new programming language called Cairo, and we're going to learn what Cairo is all about. So yeah, so there's kind of like compatibility and performance. So there's a measure of compatibility and performance, right? So yeah, we have this classification, ZK-EVM classification, right? For type 1, type 2, type 3, and type 4, right? So type 1, meaning nothing changed, same solidity. You write it on Ethereum to work anywhere that is type 1, right? So we have type 2, meaning it is compatible with EVM, but it's what slow. Anytime that it has compatibility as EVM, that means it's going to inherit all the problems associated with EVM, which is what speed. Its solution will not be executed with speed. Right? That means it's a performance issue because it's inherently it's kind of like inheriting the same issues as Ethereum because we're looking at scalability here. So we have type 3, we have differences in storage, hashes, and pre-compiles. I mean, it's kind of like a trade-off in between. There's partial, compatibility is partial. Like, yeah, we have networks like Kakarot, ZK Sync, Scroll, and Polygon. So what that means is performance. I mean, if you're building anything on any of this chain, it's kind of like way faster than you have on what? On Ethereum. Does that make sense? Yeah. So then there's a type 4 classification, which means there's a completely different word, virtual machine. That is where Cairo lies. It is not the same as what? As EVM. It is a completely different word, virtual machine, right? It is what? Very, very what? Fast in terms of performance because of different what? Virtual machine architecture. So yeah, so it's kind of like a trade-off between this and that. So if you want to inherit all the problems associated with L1, just use this classification to know what to use. So in the case of type 1, nothing changes, type 2, like that. Yeah, but in the case of what we're doing here in this bootcamp, we're trying to like expose you to a completely different language that does not rely on the EVM, right? So we have something called what? Starknet, sorry, Cairo VM. So yeah, we're looking at L1 finality. L1 finality is, we're going to talk about more about this when we talk about the architecture on what. So we're going to give you a better understanding. When we're going to eventually run nodes. We're going to see, so probably after the introduction to all of the Cairo and all of that, we're going to see how transactions work on Starknet. Basically, so you understand what happens when transaction is set to be accepted on L2, and what happens when transaction is set to be accepted on what? L1, right? So we're going to learn about finality. The time it takes from what? Initiation of the transaction to what? Completion of the transaction, right? So there's a time frame it takes. That means if that state had been said to be, if that block had been added to finality, that means it cannot be what changed. Before finality, there can be reorgs, right? A reorg is kind of like um, where is the head of the chain? If the head of the chain, there's a contention between two known chains, there can be a reorg. But if the transaction that you executed is included in a block that has been added to the head beacon chain, it cannot be what? On the head canonical chain cannot be what? Changed. So yeah, so we're going to learn how all of these things work when we move into transaction lifecycle and architecture. Does that make sense? Hello guys. So yeah, so whereas on one hand is very, you can see optimistic rule of transactions, like I said earlier, it takes up to 7 days for. So if you kind of like withdraw your asset, let's say you have USDT and you want to withdraw it on Ethereum using the normal bridging approach, the core protocol approach, not using bridge, not layer swap, not hop protocol. Which other bridge do you know? I have a lot of them, right? So if you're not using a bridge, if you want to withdraw your assets using the native bridging approach, right? You have to wait for what? I have tried it and it was not a good experience, right? I had to wait for what? Imagine you waiting for 7 working days, 8 working days. So that is the challenge that comes with using OP solutions. Right now, I think there is kind of like a suggestion for most OP solutions to leverage what? ZK. And that is the promise of the battle-tested nature of ZK. So a lot of there are considerations on how OP stack can leverage ZK because that is the feature. Because nobody wants to wait for one. Yeah, by default. Yeah. So yeah, like I said earlier, summary of what Starknet is: we have optimized ZK technology, we have computing power, increased computing power, reduced gas fees, secured by stacks, plus Ethereum, and now Bitcoin as research and development is currently ongoing. We have programming language, powerful programming language like Cairo to build scalable applications, and the network has been battle tested for over 2 years, and over $1 trillion has been moved. And you can actually withdraw your asset from to L1 within 6 hours, actually, yeah. So no trust setup. So in this next, I don't know if there are questions. Otherwise, we move on to what Cairo is so that we can explore Cairo as a programming language. Are there questions? Any questions, guys?
I have a question, but if when you are going, proceed.
Well, sure.
I have a question.
Yeah, sure.
So if I try to move my Starknet from, let's say, agents when they try value wallets to an exchange, why does it take up to a day?
Yes, thank you. Because most of these exchanges don't even want to rely on the guarantees of it can be settled within 6 to a couple of hours. Yeah. So they want to take extra precaution not to what? Allow anything to slip through in between. So if there's any it takes time. So that's why we have bridges. We have a lot of bridges that have layer swap. You pay some fees. You pay 5 USDT around that. Less than sometimes 2 to 5 USDT. For that wait, you don't have to wait the whole day. So if you want to leverage those bridges, use them so that you can actually move your assets from chain A to chain B. So in this case, an exchange. So move your asset to a wallet and move it from the wallet to an exchange. Yes. And quickly credited to your exchange account. Right. So yeah. So these exchanges are taking much time than necessary to not allow any room for concerns. Yeah. So they just want to just precautionary measures. Do you get? So yeah, so that's what that's a very good question anyway. That's a practical instance of how long it takes to move your asset from Starknet to other networks. So yeah. So exchanges have implemented this feature so that you guard against any uncertainties, right? So yeah. Any question? So yeah, so we'll be moving on to what Cairo is all about. I think we'll take a break. We'll come back, stretch so that they are a bit more refreshed and take water. 5 minutes actually, so we'll come back and continue. We have a lot to cover. So yeah, For those of us watching virtually, so you have to join us shortly in 5 minutes so that after you stretch, drink water, want to drink tea or anything, but if you go, you come back, not disappear. So we're going to reconvene and continue to talk about the next topic, which is what? Cairo. Yeah, thank you so much. So we gave an intro to what Cairo is. I think we understand all of the components right now. It's kind of like a build, although we're going to dive deeper into that, and we'll do some implementations hands-on to get a proper grasp of all of these concepts. Yeah. So the end goal after today's session, we're going to install a wallet, we're going to go to a faucet, we're going to claim some tokens, and we're going to do some transactions. We're going to go to a block explorer, in this case, Voyager or Starknet, to visualize how transactions work on Starknet. So yeah, so please note this. Starknet is not what? An EVM compatible what? Network. Does that make sense? So yeah, so there's a virtual machine that enables all of these, and that virtual machine is called what? Cairo what? VM. So if you're going to build applications on Starknet, you will know that there's no interaction with the EVM directly. Does that make sense? Yeah. So what is Cairo? Who can tell me? There is a short form. Cairo is an abbreviation for something. Who can tell me? It's like it was because of Egypt that they named it Cairo. Eh? Eh?
Yes.
Who can tell me? Eh? CPU. CPU multiplied. Algebraic representation. Algebraic intermediate representation. Algebra. There's mathematics inside. So we're not going to stress ourselves with the mathematics behind. Then, yeah, CPU, algebraic intermediate representation, O, like exclamation. Yeah, so that's what that means. I think there are details about how so if you're interested on what it's all about, yeah, so we have this, we're going to reference this later, but overall, the whole idea is the fact that we have a programming language that enables us as developers to write what? Provable programs. It runs on top of the what? The Cairo VM. The syntax is inspired by Rust. Similar, it has Rust ownership model. So if you know ownership in Rust, who knows ownership here in Rust? Have you written Rust? How many people have seen Rust? So yeah, so it has that ownership model. So it had a strongly typed traits, macros, all of those things, and it can be used outside of Starknet. Yeah, and you don't need to know ZK. ZK, polynomials. How many of us know polynomials here? What are the mathematicians here? Polynomials. You love polynomials, you love mathematics, you like polynomials. So yeah, so if you want to dive deep, fine. This is kind of like an avenue for you to interact directly with low-level workings that make up Cairo. So Cairo is like the language you write, right? It's like Rust, but it has its own, is directly targeting the Cairo VM, yeah? So you're going to learn a lot of things, but more like Rust actually, yeah? But if you want to go deep low level on what it compiles into, right? So we're going to learn all of that. We're going to learn Cairo VM, we're going to learn a lot of things. So it has a kind of like a bytecode based, how many of us have heard of Sierra? Sierra. Eh?
Sierra.
Cousin, yeah. So yeah, so Sierra, then what? Cousin is what? Cairo assembly. So yeah, if you're really interested in what happens to the eventual, not AI. So when you write a Cairo program, it compiles to what called what? Sierra, and eventually what? Cousin. Cousin is what? Cairo assembly. So this is kind of like the zeros and ones, the bytecode version of what the Cairo VM understands, yeah, to perform operations, right? But if you want to go deep lower to see what is powering it, it is being powered by what? Called CK. That is where you're going to talk about what? The polynomials, all those polynomial constraints, all of that. So yeah, so that's basically that. So what is the Cairo VM? It's the virtual machine for the Cairo language, right? So it's responsible for creating validity proofs for general computational programs on Starknet. So yeah, for every computation, it's crucial to construct what? An air for every computation. So for every computation, there's what called what? Air. Algebraic intermediate what? Representation, which comprises of what? A set of polynomial constraints that accurately represent what? A given what? Computation. Does that make sense? Hello, guys. So this is it. For every computation, there's an air. So every time you compute anything on using Cairo, right? There's a corresponding what? Air. Algebraic intermediate what? Representation, which what? Which is made up of what? Polynomial what? Constraints. So these polynomial constraints represent that computation initially. Remember, for this computation, there's an air. So what is the air? Set of polynomial what? Constraints. Does that make sense? Hello, guys. Yeah, so this is it. So if you want to go deep low level, this is kind of like a broader overview of how you can actually navigate your way to understanding that, but you need solid background of mathematics. But for now, we are not doing mathematics. We're trying to like abstract away all of those mathematical constraints, right? So that we focus more on the language itself, learn about it, learn how we can actually build applications using Cairo. So if you want, it's an area of serious research. A lot of persons are curiously. Oh yeah, so I think somebody, you know. Hey, is there a WhatsApp group? Yes, there's a WhatsApp group. Please, Janet, have you registered? If you've registered, we sent an email that captures the server, right? We have a dedicated channel for you to ask your questions. All of these slides, everything regarding what we are doing, the resources that we share in the course of this bootcamp, we'll make it available for everybody to access it. So please make sure, do well to take advantage of that Discord channel. Yeah, Cairo Bootcamp. Link is there. So yeah, all your questions related to what we are covering, please ask those questions. I will cover them as much as possible. So yeah. Oh yeah, so sorry for that. Actually shared it on the wrong slide. So yeah, so this is kind of like a depiction of what Cairo is all about. When we first like this syntax, it's completely different from what we already used to. Can you see? You can see that we have a lot of types. We have a struct. This is a type called struct. We have a type called trait. So we're going to learn how all these things work. So we're going to learn about the scalar data types. We're going to learn about what? Scalar data types. So a scalar data type is the bare bone, right? The bare bones of the bare bones. We're going to learn about the U-weights. We're going to learn about the integers, the fields, all of those things. So yeah, so the complex data types aggregate these scalar data types to form what? Compound data types. So yeah, so that is basically what it's all about. So this is U64, U64 making it just like we'll have object in JavaScript, right? So this is like a struct that represents a rectangle that has height of type. Everything in Cairo is typed, is strictly typed. So just like we don't have solidity, but kind of like a bit more advanced when it comes to type strictness, right? So yeah, very, very sweet language. We're going to learn it. We're going to have fun. Have a question?
What does he use? Substantive.
So we're going to learn it, but don't worry, we're going to get there. So unsigned integers and signed integers, we're going to learn that. So yeah. Don't worry if you're kind of like new to this kind of syntax. You are building applications that will run on the network based off this. So it's going to be something you're going to be practicing going forward. But this is an overview. We're not clear to tell you that, oh yeah, we're setting up an environment in this session. In subsequent session, we're going to install all necessary dependencies on machine, or start writing Cairo. Don't worry, guys. We're going to take it easy on all of us. So this is just an overview of how it works. So we are going to use Cairo to build a stateless what? Program. Can I clean this? Yeah, sure. Hope we understand everything happening here. So yeah, there are questions, we're going to talk about them. Please remind me as we progress. So yeah, so basically, what we're going to cover is what we're going to use Cairo for. We use Cairo to build stateless programs called Cairo programs. And we use it to build what? Stateful programs called what? Starknet what? Contracts. So yes, Cairo can be used. Cairo stateless program. Cairo program. Those people have pure functions. Remember, on Solidity, right? Pure functions don't interact with state, do they? No. You perform arithmetic operations that actually gives them to create libraries, right? Yeah. So in the same way, you can use Cairo to build what? Stateful. When you say something is stateful, it's interacting with what? With state of the network. Stateful what? Contracts. Stateful logic. Yeah, stateful logic, in this case, what? Starknet what? Contracts. So yeah, so basically we're going to be learning how we will be building all of this. We're going to build a simple calculator using Cairo. And when we're doing that, it's stateless because we're not starting with the network directly. And on the other hand, we're going to learn how to build stateful logic. We're going to be building Starknet contracts. So remember the first instance I gave you, I think, yeah. So this is nothing here is interacting with the state. This is a typical example of a what? Cairo program, because it's just what? State there, because we're trying to calculate what? Area, yeah, arithmetic calculations, right? And on the other hand, we're seeing that we're having what? Storage. Anytime you hear storage, states, yeah, know that we're interacting with what? The network. So we're looking at states. So that means this is a what? A what? A Starknet what? Contract. So yeah, so that's how that works. Now, an overview of what Cairo is, and the summary. I think we're using it, like I said, we use it to create provable program, proof of computational integrity, because we have for every computation, there's a corresponding what? Arithmetic intermediate what? Representation. So every time you compute anything on with Cairo, right? For every compute, so for a given compute, there's a corresponding what? A. Right? So these are mathematically derived what? Results. Does that make sense? Hello? For every given compute, there's what? Arithmetic intermediate, algebraic intermediate what? Representation. Representation means what is the result of this computation, right? Representation. Hello? Are you a Nigerian representative? Are you a representative of this class? Yes. Why? Because registered and there's proof to show that your metadata is captured in our database, right? So what is the representation of this compute? That is what Cairo is giving you as output. Every time you compute anything using Cairo, you have what? Algebraic intermediate what? Representation. Does that make sense? Which is a proof of what? Computational what? Does that make sense? Hello, guys? Hello? Please note that. And we have what? Verification without multiple re-execution, as in the case of Ethereum, where when we validate once, when a new state is created, multiple validators within the network will have to attest that this proof is what? Valid. So it removes all of that and then gives us a lean version that can be verified multiple times. A lean version proof that can be verify multiple times. Then we have flexible. It's very flexible. As a powerful language, you will learn that in the course of the next session as we get hands-on, and prevents cheating and malfunction, keeps a supercomputer honest. So yeah, so that's kind of like a brief overview of what Cairo is. Please don't worry, we're going to set up our environment, we're going to write code, it's going to be fun. Are we happy, guys? Yeah. So please, if there are questions, please feel free to raise your hand, and I'll go over that and clarify as much as possible. Now, we're moving on to the third component of this class, which is what? Smart wallets. Remember, on Ethereum, every time you create an account using MetaMask, what happens? Hello, you have what? What do we call that account? What do we call Ethereum accounts? I will know they are not custodial, but there's a different name for them. What is EOA?
Externally owned.
So yeah, so externally owned accounts are EVM based. So in the case of Starknet, they are not one externally owned accounts. We're going to learn about smart contracts. Every account you create on Starknet is what? It's a contract. It's a contract, yeah. We're going to learn about that. So that is why Starknet is very powerful, because it is built. It's just like somebody saying, "Oh, I built a 10-story building, and I want to modify something in the foundation to allow me to take 1,000 stories." Is it possible? It's possible. It's going to be what? Very what? Hard and difficult. Yes. Hello. So Starknet have foreseen the future, seeing the inefficiencies of EOAs. That's why it has built into it what we call what? Smart wallets. This allows programmability. This allows a lot of things to be built into accounts, and we're going to learn how that works. Yeah? Does that make sense? So yeah, we're going to learn about smart wallet. Also, what is smart wallet? I was supposed to ask this as a question, then we can based on it, then we'll move on to the next thing. But anyways, a smart wallet is a wallet that allows you to send transactions with a touch ID or Face ID. How many of us have installed a Starknet-based wallet? Braavos or Agent. Agent is now what? Ready, right? So do we have it?
Yeah.
I'm glad we have it, because some of us here want the hackathon, so why not? We use that to receive our funds, right? And we're happy. All right. So yeah, so the whole idea of smart wallets is the fact that it enables you to perform certain things that you will have difficulties performing with EOAs. We're going to learn about that. Yeah. So you start transaction with a touch ID, Face ID, executing multiple transactions, multiple operations in a single transaction. So we're going to learn about multi-calls, right? So this is a built-in feature into Starknet. Can actually perform. And people swap on a desk on Ethereum or a staking contract. You perform is approve and what? You stake. We built a staking contract, right?
Yeah.
Hello. We know it was difficult. You must first of all what? Approve. Your approval gets successful. Then you do what? Stake. Can you stake without approving?
No.
You have a ETH string token, you cannot do that. So but on Starknet, you can actually bundle two of them into one transaction and they'll be successful. That's where the place of what? Multi-cons come into play. Why? Because smart wallet architecture was built into Starknet from ground up. It's part of the whole architecture. So yeah, so on every wallet is a smart, on Starknet, every what? SN in this case, Starknet, every wallet is a what? It's a smart wallet. It's a contract, right? There are no what? EOAs. There are no externally owned accounts, right? Built using what? Account abstraction. So we've learned about a lot of things. AA, account what? Abstraction. And we have a lot of providers, in this case, Ready and what? Braavos. So what is account abstraction? So yeah, Ethereum, everything is bundled together. We're going to see the differences. But on Starknet, certain things are together. So we have a signer and we have a what? An account. Hello. So any device that signs a transaction is a what? It's a signer. So what concerns your wallet when you have probably you have it on your app, right? Your mobile device, you have your Starknet based wallet here. So what concerns this device with that app is to what? Is to what? sign transactions just to bet that you are the valid owner. And again, it identifies with your what? Your private key. Hello? Hello? But that is all. Once you have done these two things, the next step is there is a component on chain, right? Which is what? The account component. So when you talk about account abstraction, we have what? A signer, and we have a what? An account. So this account component is what lives what? On chain. Does that make sense? Hello? Are we together, guys? So yeah, so basically that's how it works. So this kind of like could be a device, probably your desktop, your mobile application, your laptop, right? And you have a browser extension that serves as what? As a signer. That signer, what does it do? It holds custody of your what? Private key and what? And you can use it to what? Sign transactions. So we're going to see how we can actually build complex logic with this, right? If you learn how to do this, you can actually build your own version of what? Braavos or what? Agent. We're going to see how it works. So now, this account component, like I said, this is a device that signs transactions and identifies the user with the private key. Then a smart contract is on Starknet. This component holds your asset on chain. So when you say I have the USDT in my wallet, the component you're referring to is what? The account component. Does that make sense? So when you sign, remember, every time you sign a transaction, it must be what? Verified. So the verifying entity is the what? The account, because when you sign here, the account what? Verify the signature is what? Valid. Does that make sense? Then you can actually execute transactions with what? Multi-core. In the case where you want to do a staking on DeFi, right? Or ERC20 assets, you can actually perform what? An approve and a stake all in one call. All possible because of this decoupling of different entities. In this case, the signer is different from the what? The account. And that is the basis for what stands Starknet apart from other networks, because it has built into it natively this phenomenon called account what? Abstraction. Does that make sense? So yeah, so let's look at this. So we have in scenarios where this slide may not hold true in the nearest future. Yeah, because Starknet is going to be what? Centralized. Right now, because of the centralized sequencers, because these sequencers are still controlled by what? Starkware. In the future, when it becomes centralized, right, it will be based on fee model. Fee model will mean how much fee did you pay for a fee for your transaction, for your transaction to be added to a particular block. I don't know if that makes sense. So yeah, so for now, currently it's based on this will hold true because in a case where we have on Ethereum, right, this is kind of like the case when you're looking at so I want to do an approve and I don't want to do a swap. What is happening? Typical scenario is we're expecting that step one, my approve action and my what? Swap action is supposed to be in the same what? Block. Every action on chain is a transaction. Hope we know.
Yeah.
Every state changing action on the network is what? It's a transaction. So I expect that my step one, which is my approve, and my step two, which is my swap, is supposed to be in this particular block, but that does not happen. That does not happen most of the times. So what do I expect? This is kind of like, you don't get this most of the time on Ethereum, right? You can actually have your step one in that transaction fixed in between, then your step two. Does that make sense? That is if you're very super fast, actually. Then you can actually have your step one in one block and your step two on a different block. That's for Ethereum. Does that make sense? Yeah. Then this is kind of like a scenario where you actually get front run because this is a kind of like a bot, a front running bot can actually front run you before your step two is eventually added to the block like that. But on multi-core or Starknet, this is kind of like very guaranteed right now, right? Can actually have step one. So at the end of the day, with multi-core, yeah, if you're performing any operation on Starknet with multi-core, it is guaranteed that all of those transactions will be added in the order you sequence them. Does that make sense? So that is why we're showing this slide. Multi-core is kind of like an approach that Starknet has built into it. So you can actually do operation 1 and operation 2, and they'll be passed as a single transaction. So let's say my approve and my what? Swap, right? Both of them will be bundled together as one what? One TSN. Does that make sense? Hello? It is possible on Starknet because multi-core is a built-in feature that enables the operation of different actions, bundle them together as one simple call, and you pay the attendant fee, and it's acknowledged on chain. But when you open the block explorer, you see that it was different operations that were successfully executed. Does that make sense? So yes, that's possible. That is what multi-call is all about on Starknet. So yeah, talking about account abstraction in practice. Is this clear? So we're going to see how it works. Yeah. So what is this guy? This guy is my what? My signer, right? We're going to see how it works. Guys, I will be happy to take you on this journey where we're going to try it out. It's very sweet. You're going to visualize it. So you can see that what's happening here. I have my what? My device where I have my what? Private key. Whenever you have a Starknet-based application installed on your mobile device, on your app, on your laptop, or your desktop, anywhere, what happens? That device is your what? Is your what? Is your what? What does it hold custody of? It holds custody of a what? So as depicted here, that signer component, as part of the account abstraction architecture, holds custody of your what? Private key. Then the next thing that happens is what? We're looking at, so, you know, on Ethereum, right? There's nothing like account contracts. If I sign immediately, what? My target contract. Does that make sense? So now, because of this intermediary, I can actually build any logic. Does that make sense? Build any logic as my contract to handle complex operations. So before, if I sign here, I verify, I do a lot of things, probably we'll see how that works. But this is, in reality, how Starknet transactions are executed from the point of what? Account abstraction. My mobile device is holding custody of my what? My private key. What do? I sign my private key on my what? On my mobile device. Then my mobile device, something is going to happen. It's not successfully executed immediately. The account contract that is on chain will have to vet. Is this signature valid? If it is valid, if you verify that signature, then you can proceed to execute the instructions that I have initiated from my signer. Does that make sense? Hello? So if I'm going to call a simple counter contract, my simple counter contract is here. Please follow up. Please, this is the basis of everything you're doing on Starknet so that it gives you a better mental model of what you're building when you're writing code. Does that make sense? If I'm going to build a simple counter contract, remember, my simple counter contract is going to be depicted as my what? My target contract. Something is going to happen. Now, I'm going to sign a transaction from my DApp. When I'm going to do that, what is happening from my DApp is what? I'm signing what? A transaction. Right? When I sign a transaction, there's a second part that's on chain. The second component of my account. The transaction is not immediately hitting the target contract. No. The account component is going to verify, hey, is this signature valid? If it's valid, then it propagates that call to the what? The simple counter contract. Does that make sense? So if I'm going to increase count, there's going to be a component here that has an implementation of what we call what? Snip what? 6. Just because we have ES token as an implementation of what? EIP what? 20. On Starknet, we have what we call what? EIP for Ethereum is what? Ethereum improvement what? Proposal 20. We have a lot of standards for accounts on Starknet. So any contract implementing Stream 6 is correct for account abstraction. You must implement these methods: execute, validate, and the signature what? Valid. So when you set a transaction here, the components responsible for making sure that it validates the signature is on chain. It's going to read this thing where you sign. Is it valid? If it's valid, then they proceed to what? Propagate that call to the target contract. In this case, a simple counter contract, as the case may be, or any contract you have built or deployed on chain. This is how it flows. Does that make sense, guys? So yeah, SNP6 is a standard. So every contract implementing SNP6 is said to be what? An account what? Contract. So that is where the innovation comes in now. You can actually build anything as an account contract for your application. So yeah, so people that you want to use your app, you can actually build improved versions of implementing SNP6. Hope you understand. We're going to learn about that in the course of this class. So yeah, signature verification. So yeah, you sign a transaction, you sign a transaction from the signer component, right, which is the device holding your what? Holding your what? Private key. The signature must be what? Verified. So yeah, can I actually deploy a programmable logic on the account component, which is the one on chain? Does that make sense? Yeah. Remember, all of these things, both of them are what? On Starknet. Does that make sense? This is the first component of our account abstraction. The second component is here. We propagate an increased count of our counter contract. It will be intercepted here, saying, is the signature valid? If it is, perform what? The action, which is what? Increase what? Count from 0 to what? 1. That's how it works. Does that make sense? So yeah. So with this in place by default, you can actually have single signers, multiple signers, that's multi-sig. Can actually have hardware signers, social recovery, session keys. We will talk about all of these things. Social recovery will mean can actually give, if I lose custody of my wallet, right? Who are the entities that can help me recover my wallet? Can actually build a logic into this account component that identifies certain parties, giving them privileges to what? Recover your account. On Ethereum, anytime your account is what? It's lost. If you lose your private key, what happens? It's gone. Otilo.
It's gone.
True or false?
True.
Otilo. You don't go. Yeah. Nobody will help you to recover the account.
No traces.
No traces, yes. Until you what? Provide the exact private key that you used for that particular account. If that is not in place, Otilo. But on Starknet, that's not possible. You can actually create the loss of an account, right? It is on you now because on Braavos, there's somebody log one, please quote me. On Braavos, there's an option to what? Set social recovery on agent, sorry, already, right? You can actually set that, yeah. You can actually give some emails access to your account in case you want lose it. If you don't enable it, you are on the same boat as the person that have lost his account on Ethereum. If your private key is gone.
On Braavos already.
Already, I know already. I don't know. I know Braavos too, right? There are social recovery. I don't know. I'm not so sure. I know already, formerly agent, there are social recovery. We call them guardians. Yeah, there are social recovery mechanisms. Yeah, you can actually send an email. So they can actually send an OTP to that email and use that email to cover your account. That is, if you have lost access to your private key, yes, it's possible. Then you can actually do a two-signer account. A two-signer adding an extra layer of security. So that when you check a transaction from your app, right, from your laptop, for instance, somebody steals your private key and wants to use it to what? Send transaction. You must approve from your what? Your mobile phone. If you don't approve from here, that transaction will fail. Why is that unnecessary? Because they've seen the inefficiencies of what? Recovering accounts in the event of theft, loss, or damage of phones. So yeah, you give third parties privileges to act on your behalf to recover your account in the event of any of these scenarios, unfortunate scenarios. Does that make sense? Hello guys. So where we build all of those logic, we will build those logic into where? The account contract. We're going to see the use cases, right? So yeah, so Starknet uses what? Starknet account uses what? Stack-friendly native elliptic curves and SEC 256K1 and then SEC 256R1, which is the standard elliptic curve for. So yeah, so where does this apply? Where does this apply? This gives us access to So how does it even work, right? Every mobile device has what? A shared memory and a what? A dedicated what? Memory. So have a shared system and a secure enclave, right? This place is where all your apps have access to. Yeah. So, but here is where we call it what? Dedicated memory, dedicated what? Processor. This is where you can actually build logic that will give you privileges to perform complex feature implementation on your security implementations on your wallet. If you're going to build any wallet, for instance, this is where facial recognition, thumb recognition is possible. So for apps like Braavos and Agent, where you have all these features, they are targeting this particular part of your mobile device, right? So yeah, applications, operating systems, they share this one, whereas on the other hand, random number generation, crypto key management, hardware signer. So if you want to turn your what? If you want to, any of you here want to turn, please, I actually want you guys to explore this route, right? Play with it, right? Target the secure enclave, that is this part that holds your dedicated processor or your dedicated memory. Use this to create, build an app that acknowledges your wallet as your mobile device as a hardware signer. Yeah, I want you guys to do it. It's an assignment actually. Let's build something around it. It's possible. Does that make sense? Hello guys. I want you guys to divide yourself into teams, and it's going to be nice if we do that. Right? So you can actually have touch ID, all of these things. If it's not the face that the dedicated memory acknowledges as valid owner of that device, you cannot sign transactions. You can actually build it, right? Just to configure this part of this account component of your what? Look at, I think we have a lot of, we can actually look at, I think there's one agent minimalistic workshops. I think we have account abstraction. You can actually take a look at it. I think I will share that later. Look at it and see how it works. Does that make sense, guys? We are builders, we're not just consumers. We're just looking at how this works, implement it. If it works, nice. We can start using your wallet. Why not? Does that make sense? So yeah, so this is what gives the possibility to applications that are leveraging your facial ID and all of that. That's how it works. Yeah, so on so yeah, it's possible. So this secure enclave is called different things for different operating systems and devices. Yeah. So yeah, for Samsung it's called Knox. For Google it's called Titan. Please, I think this is how it works generally. So let's start thinking on how I can actually build
For PC.
I think for PC, dependent on your PC, whether it's Android or whether it's Mac or Mac OS or Ubuntu or Windows. Yeah. So in that case, I think it's called differently. But at the end of the day, they have you can search about it. You can actually build a lot of, not targeting the shared processor. Anything in the shared processor, other applications can see it. But in the secure enclave, it is kind of like with the user. So a lot of tools are built off this technology, right? This secure enclave part of your of devices, right? Random number generation, crypto keys management, hardware signers. So yeah, build your own, leveraging the account component of account abstraction, so that we'll see how that works and practicalize that. Now, we talk about the summary of smart wallets, right? So we have a known fact that it gives you better UX, because if there are social recovery keys, if there are session IDs, so that if you're playing a game on Starknet, you can actually, it's kind of like a very efficient experience. If you imagine you fighting during an EVM, what's it called? Battle-based game, right? And you want to hit somebody. You know, a hit is a what? A transaction. What happens? It's a transaction. The person will die, they remove away that from the blow. Yeah. It's not every click there's a pop-up of MetaMask. Is that a good experience? So how about you kind of like bundle all of those transactions and use session keys to manage it? Yeah, that is possible because of you can actually include that logic on your gaming experience for whatever you're building on Starknet. So it's possible because on Starknet supports that by default, considering all of these inefficiencies, right? So yeah, so we have it has better UX. I think somebody listening is okay. Okay, so we have a multi-core hardware signer social recovery keys enabled by account abstraction. So we said account abstraction is the coupling of what? Signer and the account components, and it supports sign transaction with different what? And you can actually, yeah. Okay, yeah, on top that every account is a smart wallet, not an EOA. Yeah, so we're going to do this task. This is our first task for this class. So please, I think we're going to go home to do this. I think after this class, we can do this. So go to, I think we're going to install not agent, it's not agent again. It's called what?
Ready.
So yeah, it's called what? Ready. So please go install ready.
Somebody should send address.
Say what?
Somebody should send address. Let me send them.
I didn't hear you.
Somebody should send address.
So it's no, it's for you. Everybody should do it, yeah? So it's
Part of what I'm supposed to do is to transfer to someone.
yeah, we're going to learn that. Yeah.
Well, usually because I don't just get 1 to 5 for it. You understand?
Hold on. Guys, one house. Please, decorum. So this is a step we're going to follow. Let's do this and let's find. So we're going to do this after the class. I'm going to give you an assignment. So make sure you do this assignment.
So yeah, we're going to cover the Bitcoin component of what we earlier started. We talked about quite a number of things. We talked about Starknet overview. Then we went over how Starknet is scaling Ethereum, the problems bedeviling scaling on Ethereum. We know the trilemma, right? The blockchain trilemma. We mentioned security, we mentioned decentralization. Then the problem was scalability, right? So L2s were kind of like were concepts developed to address scalability issues on Ethereum. So yeah, so we kind of like dive into an introduction overview of what Cairo is. Then we talked about smart wallets. Now we know that right now Starknet is scaling Ethereum, but they've extended their tentacles to also scale Bitcoin. It is on the basis of this approach that we'll be covering the Bitcoin integration. So what is Starknet doing differently to scale Bitcoin? So now we're going to learn about what Bitcoin is. It is on the premise of what Satoshi wrote as the Bitcoin white paper that most blockchains today thrive, right? So a peer-to-peer electronic cash system that afforded us all of the possibilities of using blockchain as a solution to address the issues of trusted entities, double spending, and removing unnecessary intermediaries, right, for performing transactions. Transactions should be end-to-end from persons to persons, right? There should be no middlemen, like we have banks and all of that. So that is what Bitcoin white paper postulated as written by Satoshi Nakamoto, a pseudonym, right? Nobody knows whether it's a he or a she, right? It's a pseudonym. If you go and search Bitcoin white paper, you will read detailed information of what the idea of Bitcoin is all about. So yeah, so Bitcoin has been in existence, and there's been so many approaches to scaling Bitcoin. We have Lightning Network. We're going to review all of those approaches, and in this same session, cover what Starknet is doing differently to scale Bitcoin. So yeah, so what is the benefit, right? So Starknet and the Starkware team, they are very ambitious in their drive to scale not just Ethereum, but Bitcoin, right? So what are the benefits? Right now we have Bitcoin native staking on Starknet. So these are the things that they're trying to like bring liquidity onto the Starknet ecosystem so that it's kind of like easy for people to use their native Starknet the native BTC for DeFi operations on Starknet, and that has really transformed the scope of what is possible with Bitcoin. So with your native Bitcoin, you can actually bring it to Starknet and use it for DeFi operations and get some yield on staking your Bitcoin. So yeah, right now we know that it's very easy to use Starknet to, right now Starknet has proved this method in scaling Ethereum, but then again, they're also looking at how they can actually scale what? Bitcoin. So yeah, so the benefits includes trustless bridge between Bitcoin and Starknet, which is what we have seen so far with the recent, the whole buzz. If you have been following the Starknet ecosystem news, you've seen that they've created this possibility of bridging Bitcoin, native Bitcoin to Starknet. And the whole idea is to ensure that transactions on Bitcoin is pretty cheap, right? And also, we have a scaling approach for Bitcoin, which is Lightning Network. So Starknet is trying to serve as an alternative scaling solution for Bitcoin, and also to bring the possibilities of Bitcoin on Starknet using DeFi, decentralized finance. We have a lot of DeFi applications on Starknet that is leveraging this possibility. We have a lot of them. We have Vesu. We have a lot of guys building a lot of solutions for that. So these are the benefits, right? So we're looking at how you can actually utilize your native Bitcoin, bring it to Starknet, stake it on a staking pool, get rewards. So instead of your Bitcoin to sit idle, right, in your wallet, it is your Bitcoin, but you're bringing it on a DeFi protocol to yield for you. So yeah, so we have a lot of interest-bearing tokens, right? So kind of like a tokenized version of Bitcoin that will serve as incentive when you stake representing your stake on some of these DeFi protocols. So yeah, so it's kind of like solving the problem of liquidity fragmentation and also bringing efficient, making DeFi protocols capital efficient, right? So yeah, so your Bitcoin, your BTC is secured by Bitcoin and also on Ethereum using Starknet. So yeah. So right now, I think before the future is bright for the Starknet ecosystem, because Starknet will be the first zero rollup to settle on both Ethereum and what? And on Bitcoin. So yeah, so this is the current scenario where we have, if you want to, on Starknet, so if you want to kind of like, Ethereum is using proof of stake, and Starknet using, it generates a proof for all of the blocks of transactions that have been bundled to form blocks. A single proof is generated for that, and it's verified on Ethereum, right? So this is kind of like the whole architecture and overview. But in the future, it's not going to be only for settlement will not only happen on Ethereum, right? Settlement will also happen on what? On Bitcoin. So there are a lot of research approaches and development that is currently ongoing, and we're going to review some of these approaches, right? And the benefits and the cons, right? So yeah, so these are some of them, right? So what are the approaches right now? We have the bit VM, we have the collider VM, we have the OP-CAT approach. So all of these approaches are being researched and developed to see which one offers the most viable solution to address this concern of settling on Bitcoin. Are we following? So we have the bit VM. So we're looking at a start proof that assumed to be valid unless challenged by a third party during a 1 week speed period. So something similar to the optimistic proving system. We'll have a fraud proof that's generated within, have a challenge period of 7 to 8 days. So something like that, really. So that is the first approach, which is the bit VM approach. It has the pros, which is no soft fork, nothing is going to happen on Bitcoin. And it's kind of like I think they're about to launch. But the cons is that it's capital inefficient, and then there's a dispute period that is kind of like considered long by some persons because you're going to wait for a week, right? So anything that this kind of like brings a lot of dispute, like this kind of, some people are like, oh, it's fine, it's a good path to scaling Bitcoin, right? But again, you're looking at one week waiting window. And then we have the other approach, which is the Collider VM. So it is going to use Taproot. So there are a lot of ways for scaling Bitcoin. So Taproot scripts is one of those methods. So right now, on the Bitcoin core, there will be no soft fork. Like the current code base, there will be no soft fork on that. That means there are not going to be any modifications of Bitcoin code base, and there's no dispute period. But the thing is, it's still under development, and it's kind of like involves complex off-ramping, right? So this is the very solid approach, because at the end of the day, it's going to use Taproot. Nothing is going to happen on the Bitcoin core code base, right? Nothing's going to happen the way it is, just for it to use Taproot scripts for scaling, right? So the third approach in this case is OPCAT, right? So Bitcoin, the stack proof is sent to Bitcoin, verified on chain using Bitcoin scripts. However, it has its own pros and cons, which is on-chain verification, and it uses the Bitcoin. If you put in any Bitcoin script, so Bitcoin, if you want to write, build anything on Bitcoin, it has its default scripting language called Bitcoin what? Script. So it is going to use the native Bitcoin script logic. However, it requires the introduction of a new opcode called what? OPCAT. Are we together? So that means there's going to be a modification of the Bitcoin code base. That's a new opcode called OPCAT is going to be integrated into that. And again, there are concerns about this OPCAT. However, it is still under development, and research is ongoing to make it, to see if it is going to open up possibilities of DOS, the denial of service on the Bitcoin network. That was why, one of the reasons why it was kind of like removed. It was part of the code base earlier, but it was removed at some point. So yeah. So I think the current approach, the OPCAT opcode approach, it concatenates two values in the stack, fitting stack proof, and we have Bitcoin script able to verify the stack proof, and kind of like it was initially part of what was the case in the case of Bitcoin, but right now we have it disabled because there were considerations that it could cause DOS, that's denial of service, in 2010. So enabling it is still under discussion, and research are currently ongoing. Research initiatives are being supported by the Starknet team to see if this can also be reviewed, and of course, it's going to take kind of like a consensus between the, if it eventually happens, that's kind of like a big plus to the ecosystem generally. So yeah, then the BitVM, like I mentioned, like it has no, it's an alternative scaling approach, but no soft fork. Collider VM is also researched. One of the, this is one of the Starknet core devs demonstrating how on-chain verification of stack proof of a Fibonacci computation, right, with OPCAT enabled. If OPCAT is enabled, this is something that you will eventually see, right? So yeah, so in all of this, OPCAT seems like the most kind of like a reliable scaling approach. However, it has its risks, right? So these are some of the risks. So yeah, there's a risk of denial of service, right? So with that in mind, the Starknet team has put out a $1 million fund aimed at advancing research regarding the pros and cons of activating the OPCAT on Bitcoin, right? So yeah. So right now, we are looking at how Starknet will scale both Ethereum and what? Bitcoin. So we know that it is scaling Bitcoin using all of the approach we mentioned earlier, which is what? BitVM, Collider VM, and OPCAT, right? So in all of these approaches, remember, none of them have been fully battle tested, right? We are looking at proposals on how to better improve all of them, because research and development is currently going on to see the pros and cons of each of these approaches and eventually the one that will be adopted by the general ecosystem. So that is Starknet's ambitious move to not just scale what? Ethereum, but to scale what? Bitcoin. So yeah, making it the first scaling L2 network to what? To dual scale. Yeah, so not just Ethereum, but what? Bitcoin. So yeah, so that's that. And if there are questions regarding this, it is something you can actually join what is happening, the discussions and all of that. I think you can actually follow Abdel. He's a very solid proponent of Bitcoin. I can actually follow him. He's always researching, can actually follow some of his discussions and tweet and engagement on X, see what he's doing, kind of like very bullish about the possibility of scaling not just Ethereum, but Bitcoin. Yeah, so that is that. And like I mentioned, all of these, we hope in the future they become a reality so that we will not just see Starknet settling on Ethereum, but also on what? On Bitcoin. So if there are questions around this, I would love to address those questions. Are there questions? Are there questions, guys? No questions. So if there are no questions, I hope we know that we have assignments, right? So we've been doing the assignments. I hope we have been covering all of those assignments. So we hope that in the course of this bootcamp, after the whole the sessions, you're going to kind of like come up with innovative ideas and see how you can actually get your hands dirty, building out some of these ideas. And who knows, you may come out successful. Like we're going to not just support you with teaching, we're going to kind of like, we're going to have sessions towards the ending of this bootcamp to see how we will review some of the project ideas that some of you have and see how we can actually take it to the next level. And again, most importantly, because we are all building and learning together, I want us to get our hands dirty because the scope of all of what we're teaching you here is to make you very solid Cairo developers. Thank you so much, everybody, and I hope to see you at the top. Thank you.